Bear with me. Why is this not working? Here we are. Okay. So just to bring everyone up to the same playing field, in case you don't know much about databases, what a stored procedure is it's a way to basically put code inside of a database. So sometimes you have most databases use SQL or some way to access the data, some language. A lot of times you want to do something more advanced. You want to write in a procedural language. You want a for loop. You want to use variables. So typically there's a language you embed inside the database to do that. It has access to the SQL typically. You push it inside the database, and you do that for various reasons. You normally do that for performance, so there's a clear performance gain when you can put your application living inside the database on the remote server, close to your data. You do that for deployment, so many times it's easier to simply deploy software, so to speak, when it's just code inside the database rather than compiling and moving binaries out to your production machines. And control. So sometimes, some companies say that, the DBAs have access to the data and the application programmers don't, so we can control what you're doing. Okay, so the database we're talking about here is unknown to anyone at this point. This is a custom-built system inside of Bloomberg. It's called Comdb2. It's basically, if you squint, it looks like every other database. I like to say they all look the same if you squint. So it's a relational database system. It uses SQL. It was designed basically from the ground up to be very highly available, so that's the reason it exists. It's on its way out the door, hopefully this year, to be released open source, so people will get to take a look at it. It's the subject of a paper that was accepted for VLDB 2016, so there'll be a published paper as well to explain how this thing works soon. That being said, I'm going to try not to talk too much about the database, but I just want to get into what the heck we're talking about here. So. We needed to build a stored procedure language for this database, and that's how we came down this road here. So the database we built here, Comdb2, is a relational database that uses SQL as its relational language. I like to say SQL is a pretty standard thing. Every system uses the same SQL pretty much. We tried to pick something different for stored procedures, because if you've worked in the world of databases, stored procedures tend to have the reputation of being like vendor lock-in kind of things. That we go from Oracle, you can't really easily get to other packages. You're using their stored procedures. They're notoriously vendor lock-in anyway. Everyone kind of expects that. So I kind of saw that as an opportunity. I said, okay, SQL I kind of had to choose because the whole world uses SQL, and I'll confess I don't even love it, but I have no choice. People would think I'm crazy if we don't use SQL, right? But stored procedures, I said, okay, we can choose something different. We can try and do better this time. I don't need to follow, the same thing. So most packages out there all kind of converge on this. It's called PLSQL. It looks kind of ugly. I mean, I make fun of it. I say it looks like COBOL. If you've done any stored procedure programming in most packages, it's really it's a pretty lousy language, and people just accept that, and it's the status quo. So I said, okay, let's try and do way better. Don't want to do it. Shop for a new language. What can we do? So I went language shopping. I said, okay, Java. That's the language du jour. This was many years ago, of course. Let's see what Java looks like. Let's see if we can embed that inside the database. Embed a JVM in there. Let's flush out what it's going to look like to write a stored procedure in Java. I like to say, I didn't think of this idea. Oracle, one of their main interests in the Sun actually was Java, as we see now. They got interested in Java, and they pushed the idea of using Java for their stored procedures. They were doing this for a while. It never really took off, but that's a different story. And so I said, okay, this is definitely where the industry's going anyway. Java looks great. Let's do it. We never really got that far off the ground with Java. So Java, it didn't work all that well. The main thing that, and this is going to lead me closer to Lua, is it's huge. It's complex. It's gigantic. The code base for their JVM is larger than the database we were putting inside of. So that disturbed me a lot. It makes things very difficult to debug, basically, right? When there's a problem, and you're in the business of supporting production systems, no one really cares that the problem is some other person's code that you embedded. It's your problem, right? So you end up saying, okay, it's my problem, but I don't know how to debug it, and I can't, and it's too complicated. So we actually did experience numerous actual crashes inside the JVM. No piece of software is perfect. We weren't in the business of fixing that thing. It's kind of a monstrosity. We also found, all sorts of cute problems putting the JVM in your process to begin with. So it's very unholy to embed that thing. It plays games like, it catches signals like illegal instruction. It catches all sorts of signals inside your process where debugging your own application now becomes very difficult because you've embedded that thing. So getting it out was a good step. So we abandoned Java at some point. Said, okay, let's try Python. So I stumbled into some article, and I think it was a Linux journal. It was, how to embed Python in a C program, and it was, in 30 lines of code. It looked great. I said, okay, let's give this a shot. Let's try Python. You can embed it in like 30 lines of code. It's pretty simple, relatively simple. It seems like it's going to work. Looks promising too. Looks like a nice, clean-ish language. We learned very quickly about the enormous lock problem. So that's kind of a non-starter for us as well. So we have a multi-threaded, concurrent application. The database needs to support lots of concurrent users and can't get in the business of having, one guy running his stored procedure, the other stored procedure can't run. That's a non-starter. We can't do that. So we quickly kind of threw that out too. It wasn't going to work. So I think I literally sat down one day and typed in Google something like embeddable scripting languages. And I think this works now. If you type it, you'll probably see number 3. I think Python pops up above it actually. And I said, okay, what's this? Lua. Let's take a look at Lua. Let's try this guy. So I learned a little bit about Lua. We went down that road again. Said, okay, let's learn this. Let's see how it is. It's very easy to embed. We got it up and running quickly. It was very appealing in that, from the documentation, my first experience looking at the documentation was they wanted you to embed this thing. It wasn't like Python can be embedded. That's a little different. This was, please embed me. This was the, what the documentation basically said. I said, okay, that looks really good. That's what we want. The code was really, really small and clean. It didn't scare the heck out of me. It gave me confidence that if there were a problem, we can fix it. And that's what we need to do, because the phone's going to ring and they'll call us. They're not going to call, the people here if the stored procedure breaks. So we need to be able to fix it, and that's important. It also, and this came up in a few of the other talks here, was designed to give very, very fast, efficient access to the native C code, which is crucial. So it would be a non-starter if we had a language where it's expensive to get in and out of the C code, because the vast majority of a stored procedure is glue, so to speak. It's glue code doing database-y things. The heavy lifting is all in the database code, which is all C. So you need to get in and out of that very efficiently. So we tried it out, and yeah, it was great. Talk's over. No, so it didn't work exactly perfectly. There's a slight mismatch, basically, between as nice as it is, as great of a language as Lua is, database store procedures are kind of a little bit of a different animal. They don't quite fit exactly with, and it's not a fault of Lua, they don't fit with any of these languages, okay? They need more rigid typing, for example. They need some sort of stronger typing, because there's this weird mismatch between the SQL system and the C APIs that talk to SQL, and then you get this really loosely typed language underneath, and it's almost chaos. And we tried this, and it was very error prone. So we said, okay, how can we get some sort of stronger typing system in? And we developed something, and we're going to talk about that. How can we deal with transactions? So we may need to extend it slightly. Not sure. We'll may have to deal with how transactions fit in the scope of these procedures. Can we get some sort of threading model? We might need that as well, because that's a thing people want to do. They want to be able to break apart their queries and actually do concurrent, not coroutines, unfortunately, that they need really to run on processes and get things done in parallel somehow. And we don't really have a model for that. So that being said, with all our ambitious goals of trying to hack on the language, we had one goal all along, which we pretty much stuck to, and I don't think we didn't screw up that royally, which is make everything a superset. Everything should hopefully be a valid superset of Lua. Valid Lua code should always run exactly as it does in Lua. Everything we do is additional, and you can choose to ignore it and walk the other way if you like to. So, and many users of the database do ignore, and some use. So these are optional features, generally speaking. So we started by adding all the base database data types. That was the first obvious thing that needed to get done somehow. So the database, unlike Lua has the string, the number, and I guess an integer now. It wasn't enough for dealing with the database. So we started extending the data types. We put in all the databasey data types, reals, interesting ones are things like decimal floating points, date times. These are kind of interesting. We extended them in a slightly, they're not just user data. We've modified Lua to make them first-class data types. We kept the number and the string and all the Lua ones alone, and they act exactly as they should. We then started working on basically notions of type affinity. So basically the fact that these variables will have types and they can percolate between various layers with their types intact. So what I mean by that is, for example, this isn't exactly like a working program, but you can see this is a piece of C code here that's going to bind a variable. So there's a variable called arg in my address space here. That's C code. That's the address of it. And I'm going to say, okay, the string is arg, and then I can run a procedure, exec procedure, right? This is like pretty standardish looking thing. The @ is the bound parameter. I pass that in through the C to SQL to Lua boundary. So there's literally three languages just happen there. We need to get the right data type, right? That's the problem. So if we didn't have A, data types, and B, type affinity, you wake up with the wrong data type, which is very error prone again. So people expect they wake up with the right data type. So in this case, A would wake up with a type of date time, because that's what I bounded at 2 language layers above us. So then, I think I just lost a slide. The next thing we needed to add was basically the notions of type arithmetic. So a lot of these data types have sophisticated arithmetic properties. So for example, decimal floating point does math in an entirely different way than floating point numbers do, right? With different rules, higher precision. Date times work completely differently, obviously. So here's a silly example. You wouldn't really do this, but you have a function, and you're adding in A plus 1 month, basically, right? So the point is this is valid, date time arithmetic. If that were a date time and that's an interval, you could take today's date, if you passed in now to this thing, and then you could say add a month. That's like a thing you would do in SQL. So we tried to basically take all the expressive arithmetic abilities that do exist in SQL and let you do the same maths in Lua. So then we said, okay, we probably need to go a little further as well. So we have basically a notion of, I call it, runtime strong typing, for lack of a better word. It's kind of advisory strong typing. So you can basically declare your input arguments onto these functions. So every function works this way. Main is a special function in our dialect, because that's basically the entry point to your stored procedure. You need an entry point. So main is special. We obviously took that from C. You specify the data types. These data types are what you will wake up with regardless of what comes in. So there's basically a layer of type coercion now that will occur. So regardless of what is passed into you, because you've coded in this way, you know that the rest of your code, that is the input. It can't change on you depending on who calls you. So again, that gives you a more rigid notion of typing for the style of programming we were looking for, at least. So to summarize, we threw in a couple extensions here. We added in a cast. So basically, Lua has like 2 number, 2 string, right? The 2 family, I like to call it. It starts getting really ugly really fast when you have more than like 2 or 3 data types. So like you have like 2 to the world. So we took a concept from SQL. So an SQL has the cast operator. So you can take something and say cast this as this data type. So we just put the cast function inside Lua, and we made it a superset again. So you can use it on all the base Lua types as well. So you can literally throw out your 2 suite of stuff, and you just always use cast, which is kind of a nice, in my opinion, uniform way of programming. We extended, and this was controversial among some of the programmers involved here, extended the base Lua type function to understand our types as first-class types. So without hacker, you would get user data for these things. They're not user data, I like to say. They're first-class types. So they're extended to come out with our types. We put in the arguments on input functions. Obviously, I showed you an example of that. So basically, all functions Every function you write can have the input arguments strongly typed with type coercion happening at time of function invocation. And we extended the arithmetic operators to let you handle whatever rich data types you have. Okay, so the next thing we added to go slightly further was the declare keyword. So we said, okay, now we have inputs and arguments and implicit. We have typing from we have type affinity from the data coming in, but I can't just create a data type on my own. I can't declare a variable rather with a strong data type. So we added a keyword called declare. You can declare a variable as a type. And there's actually a reason why that's quoted, because it's actually 100% runtime. So you can do wacky things like, that's a Lua string actually. So you can do wacky things like at runtime, that comes from Lua. It's runtime. It's 100% runtime typing, but it's strong. So you can declare whatever you want. You declare multiple things. It's syntactically pretty simple. So now basically it's the equivalent. It's shorthand for local. Obviously, you're just creating a local variable of that type. But the point is, it now has type affinity. This also means that if you were to create variables of this type, and there's a function in our store procedure library called emit to emit a row to the client. So if you want to basically produce data to the client, going out through the same boundary. I talked about coming in, going out through the same boundary. The type affinity will be preserved as well. So if I created a variable and emitted it out to the client would wake up in his address space in his language of choice, C++ or Java or whatever it was. Again, the type affinity would make it through. So just an example why we care deeply about this kind of stuff, I guess. So here's an example of decimal floating point versus floating point, or Lua numbers, right? Lua numbers are just binary floating point. So if you do things like 0.1 and you add 0.1, there's 10 of those, right? That doesn't work, right? That's actually going to get false. That's the way floating points work. And everyone just kind of like, it's okay. So in some areas, that's not so okay. Like when you're dealing with money and things like that, that's not so okay. That's like pretty bad. So decimal floating points, for example, don't have that problem, right? You can actually accurately represent these numbers. So that's kind of a big thing. Like I like to say, we don't want to have Superman 3 scenarios at Bloomberg. We can't, have rounding errors making people rich. That's not a good thing. Additionally, the date time timestamp is basically regulated upon us. So in this industry, you get all sorts of interesting regulations, and the latest regulation is now every trade that you record, if you're in that business, has to have microsecond precision. So if you don't have that data type and you want to be in this business, you have problems. So, okay, now we have microsecond precision date times in our database because that's what the government said we have to have. So we're in this business of basically we need some of these data types. They're not just like fun projects. We need them. So some more things that we stumbled into. Sorry. Some more things we stumbled into as we were trying this out. I think I recall stumbling into this myself. Is basically you declare something and this looks like a harmless mistake, right? I declared something as a decimal and then I assigned it to that 0.1. I screwed up again because what just happened there. This is how Lua works. Obviously, it's not doing anything wrong. This is me not understanding Lua clearly, but that's now a number, right? That's now a number. It's not a decimal anymore. That's what Lua does. So I like to say it's to the confused programmer, it's like you've lost your type in some sense because you just made an assignment in Lua. That's a number. It's not a decimal anymore. So we said, okay, maybe this could be some syntactic way to make this more obvious. So we added the colon equal operator. So colon equal assignment works differently. Colon equal assignment is basically make a coerced copy of that data. So it says, take the data type of the guy on the left side, take the data on the right side, coerce it into his data type, and point to a data thing. So this is a type preserving assignment, basically. That's the purpose of this. So you do things now where you say, in this case, so this is an example of this screwing up on you, right? I print that, it's a string. If I print this here, right, colon equals quote point 1, I've just type coerced that thing. That's not a string anymore. It's still a decimal. It stayed. So it's a type coercing data preserving assignment. Okay, the next thing we did was, let's see, we added the function. Let me skip this slide here. Okay, the next thing that kind of bit us a little bit, again, you know, this is kind of, if you can Google this and find, you know, on Stack Overflow, people get bit by this all the time, but it's not that hard to figure out in Lua, which is, you know, when you're indexing into a table, 1 and, you know, the string 1 are not the same thing. Okay, so people, you know, they tune number, they tune string, and they figure it out. Again, these things get harder and harder when you have a lot of types, though, right? So these little stupid problems become really commonplace when we have, you know, we have like 5 or 6 different types of number types in the database here. So it's very, very easy to make these mistakes. So we said, okay, what can we do here to make these mistakes less silly? What we do is basically, we basically do coercion again through indexing into the table. So if I index into that table with any sort of numeric type or a Lua number type, they will all be coerced. So if I'm, and this is basically an extension again, so only if I stored the data with my types does it work this way. If I stored it with a Lua type, with a Lua number or a Lua string, none of these features exist. If I store in the table with my types with a decimal or any other extended numeric type, then type coercion does take effect. So then I can do things like say, my table 10 will find this thing. Even though this thing under Lua is not the same, it'll type coerce and find it. Because this was getting to be a ridiculously common error as well when we had too many types. Another thing we had to extend was nulls. So Lua has nil, obviously, but that's not quite the same. So in SQL, we have the notion of every data type has a special value, and that value has to be outside of the representable range too. So for example, if your number is able to store 0 through 10, there's another value called null outside of that range that needs to be represented. So we added in some helper functions. You can set null, you can get null. There's a null global variable to make, it's just syntactic sugar really. Again, the reason nil seemed like the obvious appealing thing, but nil fell short of what we needed in a couple ways. So nil in Lua is a data type itself, right? It's not a value of every data type. So that screws up the SQL model. We need that to be a value of a data type. Additionally, so table behavior in Lua, for example, is if I set something to nil, it goes away. That's not what we need, obviously, either. We need to be able to set something to null and it stays there. It's null now. It's not gone. So it's not quite the same. So we end up with nil and null now. Yep. Okay, so we added transaction support. Am I going too slowly? We added in some support for transactions. So basically, in SQL, every statement runs as an implicit transaction. So that is basically if you insert something, you update something, whatever you do, that's a transaction. The model needs to be basically, you're executing a procedure, that's a transaction as well. So it's just another SQL statement from our point of view. The whole thing needs to run as one transaction. What did that really mean for Lua? It didn't mean too much in terms of changes to Lua. It meant basically we have to deal with a return value now. So we handle a return value, and the return value is special because we need to know basically if that thing is returning, it should commit or abort. That's how we handle a transaction now through the return value. So just like if I run that insert statement, then it might get a duplicate key and blow up and not work. This Lua procedure, all the steps it runs will be rolled back at the end. Whatever SQL it did, whatever happens, it'll be rolled back at the end if it hasn't finished. The next thing we added, I'm going to finish very quickly, is threading. Threading in Lua in Comdb2 is a little different than regular threading. So we follow the pthread model. We let you create threads, but it's really a lot more like the forking model in the sense that while you have threads, because it's a Lua virtual machine, you don't have access to anyone else's address space, obviously. So it's nothing like real threads. It's more like forking. It's a very primitive system. We let you basically create threads, join on threads, and have very basic communications with temp tables. Here's the API. You can create Lua functions natively. This is kind of cool. So imagine I want to extend SQL Here's an example of basically extending SQL on the fly. I can add new functions to SQL using Lua. I can I can have the database implement triggers in Lua. So here's how we build a logging system in Lua. Here's some Lua code that basically is going to create a table that's going to be an audit table in JSON, recording everything that happens to the database. So in conclusion, Lua turned out to actually really work well for us. This wasn't an experiment. This is our production system. This is what we use to this day. We're using stored procedures built in Lua. It's 5.1 based as of now. We'll probably get around to upgrading at some point. We do all this work in Lua. We did make some changes to it, but they were all basically fairly simple changes. We added the optional typing and the threading and a few other things, but by and large, it was a great choice for us, and it's worked out well. All right, thanks.
It seems that optional typing was made so that someone could write regular Lua code and it will still function the way it was supposed to be.
Correct.
But it also seems to me that while programming this way, it's pretty much best to use the new types to avoid...
yes, my advice to people working at my company is yes, use strong typing, but it seemed like a bridge too far to say we're just completely incompatible with Lua. I didn't really want to go down that road. It seems like, because we ourselves, we've embedded, there was an example I blew through in there of like a JSON library, right? We will take code from the internet and we expect it to work, right? So we don't want to like just utterly go to the point where it's not Lua. That seemed ridiculous. So it's more of a best practice now is when you're writing a stored procedure, use strong typing.
Okay,
yeah.
But is it still useful to you or is it someone still writing code that doesn't use the new types, the strong types?
Some people do, by the way, absolutely, and it works. There's nothing, if you're very careful and precise about, converting, to number, and if you're careful and precise and you know what you're doing, you absolutely can code that way. Yeah. And
last question, what did you do about Boolean values?
We didn't actually touch, believe it or not, the database itself has no Boolean type, so I didn't have to tackle that problem.
Yes,
I don't know.
Those are the same. I was wondering if you did.
Yeah, no, we don't support a Boolean, so I never solved this. I never thought about it.
Okay, thanks.
Can you use a variable to define the type of an argument of a function?
It's entirely runtime. It's very dynamic. It's dynamic strong typing, right? It's a thing. It's entirely dynamic.
Other questions? Oh, there was one.
Hi. I'm curious as how you implement that because syntax is deeply changed. So you changed the source code of the Lua VM.
Yes.
Have you considered to use maybe a preprocessor that generates Lua code, or it never occurred to you?
I don't think we ever thought about that. I don't know. We got one of the programmers here. I don't think he thought about this. No, I mean this is this was a very specialized application. Think of it that way. This isn't meant as a generic proposal to Lua in any real sense, other than. I mean, I think we got someone talking right after me about strong typing as well. So I think there's definitely a lot of interest in strong typing in Lua, but this isn't necessarily the way to do it. This is just what we needed for the database.
So making those guesses, especially in the table, would be very hard to do with generated code.
Yeah, I've literally never thought about it. I don't know. Anything could be done, I guess. There's changes to the VM, yeah.
Okay, thank you. Please, another round of applause. That was all.
Thank you.